Hello, ladies and gentlemen. Welcome to Math 30-1, Chapter 5, Lessons 1 and 2, Graphing and Exponential Functions. Now, question 5. The functions you made above are exponential functions. Why do you think this name is appropriate? Well, they're function... Oh, stop that. People are watching. Computers. Why would we call them exponential functions? Try this again. They are functions with exponents. 2 to the x or 1/2 to the x. They have exponents. Now, next question. The graphs of three functions are shown below. Okay, don't work. Try this again. The graphs of three functions are shown below. Which graphs might represent exponential functions? How do you know? Well, offhand, no, because this looks very much like a plus x squared. Offhand, no, because this looks like a plus x cubed. Notice I'm not looking for the equation itself. I just want you to recognize the general shape. This does look like an exponential function. And since it's decreasing, greater than 0, not greater than or equal to, it can't equal 0. All right, don't erase. God, computers. Stop that. But it'd be less than 1. Definitely an exponential. And it's because it is decreasing. I should write that out. All right. Now, next question. Could each table of values describe an exponential function? Justify your answer. Well, the first one is yes. Now, how do I know that? Well, I look at my table of values. Divide by 10, divide by 10, divide by 10, divide by 10. So it's decreasing. I was like, God help me, times 10. Times 10. I'm sorry, ladies and gentlemen, coffee hasn't kicked in yet. Times 10, times 10, times 10. Now, if you want to take the time to graph it, go for it. You remember how to do that on your graphing calculator. Statistics, edit, you put in the data, scroll up, clear your data, clear it, and then it's -2, -1, 0, 1, 2, 0.01, 0.1, 1, 10, 100. Enter. Then you'd have to graph it. So, my windows. I go -3 to 3. X scale 1. Now notice my Y scale starts at pretty much 0, but I go to 100 in groups of 10. Now, I forgot Y equals. Clear that. Go up to plot 1, highlight it, then graph. And there we go. Now, I draw the graph. I don't have to draw the graph because I can plot the data, because I can calculate exponential function. Remember how to do that? 10 to the x. So y equals 10 to the power of x, graph. And there we are. I'm hitting those data points. And I look at my data table. I go up in groups of 1. There we go. There's my data. So, I did all that work to prove it. Don't have to. Now the next one is also a yes. Because here you're dividing by 5. You don't believe me? Pause the recording. Do it. Now, the third one is a no. Down, 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 up. 94101, this is going up, so I'd say it's quadratic. It's not divisible by anything, by any constant number. It's not a multiple of any common number. So that's definitely no. No. D is the one I want to look at a little bit. 0.03, 0.09, 0.29, 1, 3.4, 11.56. No, this one's confusing. Grab your calculator. What do you multiply by 0.03 to make 0.09? Times 3. Now, what do you multiply 0.09 by to make 0.29? Let me show you. .29 divided by 0.09, 3.22222. Zero 0.29 to 1. 1 divided by 0.29, 3.44. Now 1 to 3.4, I know it's times 3.4. 11.56 divided by 3.4 is 3.4. 39.3 divided by 11.56 is 3.399. Now, I'm deliberately showing you this one because I'm not certain. Could this be rounding off? You're only going to 2 decimal places. Maybe if you went to 5 or 6 decimal places, it would be more constant, or everything would be approaching 3.4. Now, when you graph this, you definitely get an exponential function. I'm not going to graph it, but I want you guys to graph it, plot the points, and you get, oh, it definitely looks it. I suspect this is a rounding off error, so I'm going to go yes-ish. It's not perfect, but it certainly does look like. The question goes, could each table of values describe an exponential function? Could? Okay. Could? Yes. Ish. It's not perfect, but it's pretty darn close. Now, here, yes, sorry, my apologies. Let's go on. Given the exponential function y equals 2.4 to the x, determine the following. Determine y of x equals 5.8. Now, some of these are pretty straightforward, so you grab your calculator. This is y equals 2.4, 5.8. Y equals 2.4 to the minus 1.3. That grab Mr. Graphing Calculator. 2.4 to the 5.8, I got 160.4. And 2.4 to the minus 1.3, I got 0.320. Check my math for me, please. Now, so far so good? Good. Now for the rest of these, you got to graph them. y1, 2.4 to the x, y2 equals 3.7. All right, I'm going to start with these two. Now I'm going to pause the recording. I want you to graph them and tell me your results. Okay, so graph these. We'll come back and compare results. All right, guys, for this one, I got x equals about 1.49 something, something, something. I'm not going to. And for this one, x equals 3.5, yes, 3.57 is what I got. Okay, now the last one is sneaky. Why is it sneaky? Well, y1 is 2.4 to the x. y2 is minus 22. What happens when you graph those? Come on, look nicer. Well, like I said, when you graph them, this is 2.4 to the x, and where's minus 22? Down here. No solution. Domain x is all real, but for a y1 range, y is greater than 0. So this minus 22 is outside of our range. No intercept point. Now I'm going to stop here, and then we're going to go on to the rest of the questions, okay? Any questions, shoot me an email. Otherwise, good luck.